forward, we're going to bring forces into the situation. Up to this point, we've just been dealing with how motion, velocity, acceleration all relate to one another. So we're going to move into Newton's second law, which I assume most of you are familiar with, and that is that the sum of the forces equals mass times acceleration. In statics, this equaled 0 because the acceleration was always 0. Now our acceleration equals something. So, and this is clearly a vector equation. So sum of the forces in all the directions equals the mass times the acceleration of the particle in those directions. So free body diagram would have all the forces acting on it. You can sum them together, get a resultant force, set that equal to the mass times the acceleration of a particle. Okay. Now, if we're looking at system of particles, so here I've got a whole bunch of particles, and each particle has several external capital F forces and internal lowercase f forces. Now, the internal lowercase forces are basically forces between particles within the system. So the little f is basically two particles hitting one another. Okay. Now, Newton's third law tells us that every action has an equal and opposite reaction. So if I sum up all these internal forces, there's always going to be a corresponding opposite collinear force to cancel it. So basically that goes away because of the third law. And I'm left with essentially the sum of the external forces equal the sum of the mass times the accelerations on all the particles. Now, remembering back to our definition of center of mass. Okay, center of mass, the location of the center of mass is essentially equal to the sum of the location of each particle times its weight. Getting gravity out of there, that goes to mass. Okay, so I can rewrite for a system of particles is the sum of the external forces times the total mass of all the particles times the acceleration of the center of gravity. So if you have several particles, you can approximate it that way. Okay, it's the sum of the forces equal mass times acceleration. Okay, so for rectangular coordinates, we can break this up into three components, which is the sum of the forces in the x equals mass times acceleration in the x, sum of the forces in the y equals mass times acceleration in the y, and sum of the forces in the z equals the mass times the acceleration in the z direction, which is a pretty simple relationship. That's the equation of motion that we use when solving particles that have forces acting on them.